Hi everyone. So I wanted to include this video that goes over how the calculation for covariance translates into a graph of your raw data. So in the example that we've been talking about, we've had X and Y data, where our X data is going to be temperature, and our Y data are ticket sales. Okay, so say our raw data looks like the following, and I'm going to draw a bunch of dots, so just bear with me for a hot second. Okay, so say this is what your raw data looks like. It is upward sloping, which is what we discussed. So as temperature increases, so going from super cold, like freezing, all the way up to say 100 degrees, your ticket sales for the Texas Rangers should increase as temperature increases, which is what is happening. So if you go across the x-axis, you'll notice that as you go from low values, like over here, of 0 up to higher values of the temperature, ticket sales are increasing. There's that upward sloping trend in the data. So in fact, I want to write down the numerator of the formula for covariance. And really, I'm just going to be a little strategic in how this looks. So I'm not going to write the sum I equals 1 to n. Instead, what I'm going to do is I'm just going to write what's in the parentheses. So xi minus x bar multiplied by yi minus y bar. Okay, so what I'm going to do now is I'm going to say, okay, what if we have this raw data? It's not just a random picture. You actually have the data. And you are able to calculate X bar and Y bar. X bar is the average temperature in your data. Y bar is the average ticket sales in your data. So again, temperature, I didn't write this. It's in degrees Fahrenheit. And ticket sales are in dollars. Okay. So say we do that and we find that X bar is right here. So this is X bar. And we find that this value right here represents Y bar. So notice that this breaks up your graph into a couple different quadrants, So I'm going to label them. So say this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. When we do that, notice that the majority of the data points fall into quadrants 2 and 4. So what I want us to do now is to, I'm going to get some different colors here. Let's do purple first. So let's pick 2 points that fall into the quadrants that have the most data points. Okay, so for us, I'm going to choose this data point right here. Okay, so that data point has a corresponding temperature and a corresponding ticket sales. So assume that each dot here represented on the graph is a day in May. Let's say it's a day in May. So all of this data, which I'm pretty sure we have more than the number of games that occur in May, but you understand what I'm getting at. So each of these data points is a ball game at home for the Texas Rangers in May. Maybe it can be May and June. Okay, so this specific data point, I'm going to dash down to the x-axis, and let's say that this particular day is May 15th. So for us, this is the temperature on May 15th. And the ticket sales for that game, if we dash on over to the y-axis, are here. This is Y sub May 15th. Okay, now let's write this out. So for May 15th, take a look at what the numerator of your covariance formula would look like. So xi minus x bar. Let's take a look at this first parentheses. The xi value for May 15th actually sits, this purple guy, he sits above x bar, which means everything in these parentheses would give you a positive number. So instead of giving you numbers, we know from the graph that if x sub May 15th is to the right of x bar, that means that everything that's in this parentheses should be a positive value. Okay? So for the y, notice that y for May 15th, or ticket sales for May 15th, are above the average. They're above y bar, which means yi minus y bar is also going to be positive, which means that is going to give you a positive value for the covariance for that particular data point. I chose that data point because it shows up in quadrant 2 that has a ton of data points. Now, the other quadrant that has a ton of data points is quadrant 4. So I'm going to use green now. So in quadrant 4, let's focus on this dot. Oh, and I think we'll keep it there. Is that data point right there? So if we dash down to the x-axis, that is x, and say that day was May 1st. For May 1st, notice that the temperature was lower than the average in our data, which means that this first set of parentheses, this value would be negative. If we dash over to the y-axis, this will be y for May 1st. And notice here that the ticket sales for May 1st were below average, which means this second set of parentheses in our covariance formula will be negative. Which means if we multiply a negative times a negative, you should end up with a positive number. All of this is to point out the fact that if you take each of these data points and you go through the exact analysis that we did on this graph, where we're finding out what is xi minus x bar and what is yi minus y bar. If we bother to do this in Excel with the raw data, we would find that we have more data points in quadrants 2 and 4 that give us a numerator for the formula for covariance that is positive. We do have data points in quadrants 1 and 3, and if we pick those points, what we would find is that the numerator, what's written here in these parentheses, that the numerator would be negative for the data points that show up in quadrants 1 and 3. But there's way more points in quadrants 2 and 4, so that on net, your covariance would end up being positive. Okay? So you can go through this same scenario if you want to prove it to yourself, assuming a negative relationship between two variables. Now you would need to switch temperature and ticket sales to something else, like rain, amount of precipitation. So the more rain there is, the less ticket sales they should be. So you can try on your own looking at data or going through the same analysis when instead the picture looks like what I'm drawing now, where on your x-axis it would be rain amounts, and you could just keep your y-axis the same, ticket sales. when you draw your quadrants, when you draw X bar and Y bar, you'll see that the quadrants now have more data points in quadrants 1 and 3. Okay? So go ahead and take some time and prove this to yourself. So the whole reason why we get a positive covariance if our X is temperature and our Y is ticket sales is because most of the data points lie in quadrants 2 and 4, meaning we would calculate xi minus x bar to be positive and yi minus y bar to be positive if you're in quadrant 2, or we would calculate xi minus x bar to be negative and yi minus y bar to be negative if you're in quadrant 4. But on net, the numerator for the covariance, regardless of if you're in quadrant 2 or 4, will be positive. Thus, total covariance between the two variables will be positive.